Yes, hello, my name is Casper Thompson from 3dartist.dk, and today I'm going to share a little thinking particle script that I made that creates this roll-up effect and how to do it. So this is actually what we're going to be creating. As you can see, it has this kind of Transformers-like look to create this rolling effect where you actually can put any kind of mesh you want into this and then create this kind of building up effect. It's actually inspired from Paul Kleeman's headphones tutorial where he made this effect using Cinema 4D. However, I've been using 3ds Max and thinking particles to create this. And here's a little demo of what it can be used for. So as you can see, this effect takes nearly any shape you have and create this effect. So I'm gonna show you how I did this with a simple cylinder. Where I've been first, let's have a look here. Where I started out with a simple cylinder like this. Nothing special about this. It's just a cylinder that I put a shell modifier on, and then I proceed to use the Volumebreaker from Cebas to fragment it into these blocks. You can use Rayfire or any particular script that you want. However, I found that the Volumebreaker modifier actually works pretty well. And of course, after this, it's just a matter of putting it into thinking particles, where I will set up the entire script and show you how to do it. So let's get started. Okay, so here we are from an empty 3ds Max scene, and I'm gonna show you where we begin. So first of all, I'm gonna set up a few layers that I like to work in layers because it's easy to manage all my objects like that. So we're gonna have one layer called fracs for the fragments. I'm gonna have one called GP for the thinking particles, and that's about it. So let's make sure first of all we are in this default layer, and I'm gonna create a cylinder. This can be any shape size or whatever you want, and I'm gonna just type in some default value that I used before, like this, and I'm gonna make sure that it's segmented. I like to use in the power of 12, so 12, 24, or 48, because that then I make sure that I have the edges on each of the axes, so it's easy to cut. So let's go with 48, so it's nice and smooth. Then for the height segments, usually this doesn't matter. However, when I'm using fragmenting plugins like Rayfire or the Volumebreaker we are going to be using, I like to make sure that we have some decent topology to work with. So let's put this up to 40. That should do it. And that's about it. I'm gonna right click and convert it to an editable poly modifier, delete the end caps, and select a few of the edges and press delete. So now we have this nice hollow cylinder. I'm gonna on top of that put a shell modifier and give it some thickness like this. So this is pretty much the base. I'm gonna just call this cylinder. So from here on out, I'm gonna first of all just center the pivot point. I like to do that, and make sure it's in 0, 0, 0. And then just make an editable polygon to collapse the stack. So next up, I'm gonna put the Volumebreaker modifier. This is a Cebas plugin, so this is not something you will have by standard. However, you can use some of the scripts that you can find online, or Rayfire for that sake. However, I like this because it has the brick function, so it actually cuts up bricks instead of using the Vernori. What's it called? Yeah. Anyways, sorry. And I'm gonna put in some settings. One thing that you have to kind of take care of when you're using this is that if you go too low with your values, you will see that it will start cutting because it can't really figure out how to cut the rest. This is I'm not sure it's a bug, however it's just how it works. So sometimes you will have to do this in multiple passes, where you will do first big bricks and then take the big bricks and then individually use the volume break on them afterwards. However, this is, I found that 10-5-10 is fine for this little test, and you can use the noise variation to get some of the variation. You can see it starts to cut, so we might have to set this to 7.5. Yeah, so now we have the entire mesh again. For this, I'm not gonna use any of the other things that this can. However, if you go down to elements to nodes, I'm gonna, in the prefix, write fracs, and I'm gonna make sure that my fragment layer is the one I'm actually working on, and I'm gonna say varicolored center pivot, and then just say copy and hide, and this will take a few seconds, however, depending on your mesh and how many fragments you have. So as you can see, we still have our cylinder. That's what I like about Volumebreaker. It is not destructive in that way that your meshes are destroyed. So I'm just gonna unhide this again and select it, and then I'm gonna disable the Volumebreaker. If you don't do this, it will keep calculating the Volumebreaker every time you move your time slider, and that can take a lot of memory from your computer. So I'm just gonna unhide this again. Now, when we have all these small fragments, you can see we have to do a few things before we go into thinking particles, and the first thing is to make sure that the pivots are placed correctly. Since this script actually uses the local axis to rotate these on, we have to do a bit of manual work, but it's not too much, depending on how many fragments. Depending on how close you're gonna go to the effect, you might need to pay more attention to this than I'm currently doing. So first of all, I'm gonna make sure that all my pivot points are centered. As you can see, at the moment they are offset, and we don't want that. So I'm gonna see center to the objects, and then I'm gonna use a script from Soulburn scripts. If you don't have these, you can go onto the internet and search Soulburn scripts by Blevins, and it's a pretty nice collection of different Mac scripts for Macs that takes many of these small annoyances you might have and actually makes scripts that can do all kinds of things for you. So I'm gonna open Soulburn's, this is the script lister it's called, and in this long drop down I'm gonna pick something called the put pivot and press do. So this is a little script that can be used to transfer the pivot point on many objects at the same time to some of the extremities of it. For example, I have this little part selected. I'm gonna isolate it so we can work with it. So what I actually want is to have the pivot point placed like a door hinge, meaning I would like to do this, for example. So when I rotate it, and I'm just gonna pick Logan to make sure that I do it in Logan, you can see this have the kind of door hinge effect, and that's kind of the base of this build effect. If you put it in the center as it is now, you would just have this kind of flip effect, and that's not really what we want. So we're gonna use the put pivot, and if you take and put local, you will see that the Z axis is downwards. So it should be this. Yeah. You can click the small dots to place it, and you might have to try a few times before you get it right. However, this seems to be the right one for this, so I'm just gonna exit my isolation, select all my fragments, and press this button. As you can see now, the pivot point for all my fragments has been placed correctly. I'm just gonna take off shaded, or else this might not be as smooth as I want it to be. So this is actually nearly everything. The next thing is that we need to rotate the pivot points, and this can be a pain in the ass if you're working with more organic shapes, because you're gonna have to do this very carefully to get the right effect. However, for this cylinder, which I cleverly chose, it's easy and fast to do this. So what I'm gonna do is I'm gonna select a bit of the measures. You can see I'm in the front view, so I can select the entire row here, and depending on what your object looks like, you might gonna have to use top and maybe even select manually from perspective and like that. However, for this works fine. And I'm gonna say effect pivot, and as you can see, we get these large axes. So what I would like to do is that the Z axis actually points along the surface. So if we look from the front view, I would rotate it like this. Sorry, don't use the local. We're gonna rotate it like this, and as you can see, we now have the green axis pointing outwards, the red pointing towards the surface, and the blue one in this case in the wrong direction. However, it doesn't really matter because we're not going to use it. And this is, when you do this the first time, you're gonna have to remember the way these are placed, because you're gonna have to replicate it on all the others. So with this done, I'm just gonna right click and hide so we don't select them again. Select the little portion and rotate it. And I'm just gonna do this fast. However, you might wanna be more careful in this stage because it's quite vital to the effect. And if you're good at scripting, you might even find a script that does this for you. However, I'm just gonna do this real fast, like this, and we're nearly there. I'm just gonna, and the more careful you are, the more placing this, rotating this pivot points, the better the effect is gonna be. However, for this purpose, I'm just gonna do this quite fast, like so, and like so, and like so, and the last one here, let's put it like this. Alright then I'm just gonna right click and say unhide all, and of course we get the main cylinder. I'm just gonna hide the default layer once again. So this is actually done for now. So next thing up is starting thinking particles. So let's go into particle systems, thinking, and add a single one, and I'm gonna add it down to the thinking particles layer. So let's open thinking particles. I don't have a lot of space to work with here, so bear with me. I'm just gonna scale these things. I don't know. Normally I work on a second monitor too, so whoops, like this. Alright, so I'm just gonna do it like this so we can see from the different views. Okay. First of all, we're gonna set up the particles group, and for this tutorial, I assume that you know at least a bit about thinking particles. This is not a starter tutorial, so I'm just gonna move a bit quickly from everything. So if you don't know anything about thinking particles, that I recommend you that you find some of the standard tutorials and look them through to get how the systems work. So groups. Let's start with a main group. I'm gonna call this particles. They could be fragments or anything. Then we're gonna have an inactive group, and let's give this a red color, and say show mesh, and say none here. This is the standard way to show the meshes of the particles. I'm gonna have a new group, and I'm gonna call this active, and under this I'm gonna create a new one called fast. I found that for this effect to look real nice, it's good to have variation in how quickly these things rotate. So I'm gonna have two groups, one called fast. I'm gonna give this a greenish color, and once again say show mesh and none, and a new one called slow, and I'm gonna give this a bluish color just so you can see the difference when we're creating the particles. And I'm gonna say show mesh and none. So this is actually the three groups we're gonna be working in. I'm just gonna take this up so we have some more screen space. Now let's create the rule set. So first of all, I'm gonna in the master dynamic, remember to uncheck force this setting, or else you won't be able to see the meshes. And I'm gonna create a new dynamic set, and I'm gonna call this build up effect. And I'm gonna create a sub dynamic set again, and I'm gonna call this inactive, and I'm gonna create a new one called active. And in the inactive, this is I kind of like to build my dynamic sets up in different sub layers, so I can, for example, easily deactivate all the active layers by just right clicking this. So when, for example, if something doesn't work, it's easy for me to quickly unhide the things I don't need to debug. So one more thing in the inactive, we're gonna create a new subset, and I'm gonna call this O2P, or object to particle. So this is where we're gonna create the actually take our fragments and create particles from them. So I'm gonna right click out here and say operators, generator, and object to particle, or obj to particle. And I'm gonna say pick and press H, and I'm just gonna write in frags because we actually added as a prefix, so it's easy to select them. Then just pick the top one, and remember to press this button that's called changes affect all, and we're gonna, there we go. So for group, we're gonna put this in inactive, and we're gonna check object to particle, instant shape, and then normally you can press hide. However, I like to just hide the main layer so they're easy to get again. And then after going back and forth on the timeline, you should see it's updated. And now everything here is a particle. You can even see the red color we gave the inactive group up here. So that's great. Now I'm gonna create another sub dynamic set in the inactive group, and I'm gonna call this set params, or set parameters. And this is where we actually gonna create the initial offset in rotation that they're gonna have. So we're gonna right click here and press groups and press inactive, so we have all our particles. And to make sure this only happens once, so we don't waste the CPU and calculating this for every frame, I'm gonna use a particle age condition, and I'm gonna set this to born, or it's the standard, and place this on a particle. So what we're gonna do now is use on the operators standard, there's a one called set alignment, and this is actually the node we use to rotate our particle. So we're gonna drag from particle over to our inactive particle group, alignment to the particle 2, and in this little green input here called inputs, you can right click and say on, so we make sure that it only when the particle is born this alignment happens, so it only happens at frame 0, in this case when the particles are born. And now it's time to figure out what axis this is that we have to rotate them on. I've tried this before, so in this case I know that the x-axis is what I'm going to use. For example, if you set this to 19 and we drag a bit, you should see that all these things are, sorry, that is actually not correct. Let's try this one instead. So you can see this is actually a little guessing game for what is actually the right. I actually think that this one is the correct one, if I am not mistaken. Actually, yes, X, sorry. Sorry for this. So I'm gonna put 180, so they are actually totally flipped from the first get-go. Yeah, this should be right. Okay, so we have this kind of creeple effect. Anyways, so the next thing is to when this done is actually to activate these, and for this we have to get a dummy inside. This is actually activated using a distance, so I'm gonna create a new layer, and I'm gonna call this dummies. This is because in big scenes you might have a lot of dummies, so I like to again use the layer system to keep my scene clean. I'm gonna create a dummy, and from this time it's from the top view, and I'm just gonna drag it out like this. The dimensions doesn't really matter for this, it's just so it's easy to spot. And I'm gonna call this the target. And since we are using actually animated, I'm just gonna set this to 150 frames. And I'm using PAL because I'm in Europe, so you might use NTSC instead. And I'm gonna animate this dummy 100 frames forward. There we go. And I'm just gonna drag it to the other side like this. So now we have this simple little dragging motion. You can use more advanced what's called directions or animations to activate this. However, for most part, I think that a linear moving object is probably gives you the best effect you can get. So we're gonna create a new one here called the activator, or activate. In this one we're actually gonna take the distance from this to one of the fragment particles, and if it's between a threshold, we are gonna move it over to either the fast or slow group, depending on some of the other factors I'm gonna put up later. So let's start by taking the inactive group, and we're gonna right click and say conditions, standard, and there is a distance here. And depending on your scene scale, you're gonna have to fiddle with these. However, as far as I remember, 50 was right for my scene scale, so you might have to fiddle with some other values here. That depends totally on your object, your distances, and your measurements. And so now we're gonna have to get the target into this, and instead of making a particle, we can just use a helper node. So if you're gonna helpers, standard and node, and then you can pick the target. There we go. As you can see now, so this we're gonna have to plug in one position and a particle position. And if it is between 0 and 50, this one is gonna output true. This is a boolean, so it can either say false or true. And we're gonna then create an operator under standard. There's one called group, and this group is used. This node is used to get a particle from one group to another. So let's say group, and in this case for the start, just pick the fast group. We're gonna set up some logic to differentiate between fast and slow later on. And you're gonna take the output from the distance and plug it into group, and then particle to this particle. So that means now that I'm just gonna turn it on. If and particle from the inactive group is within 50 units of the target node, this one is going to output true, and then the particle is going to be moved to the slow group, or sorry, I meant the fast. And to pick the fast one, there we go. So if we toggle on wireframe over here, you can see the color, and that's how we're going to differentiate. And as you can see now, as the things move closer, everything starts to turn green, and that is because they move over to our fast group. As you can see, the color corresponds to this one up here. As you can see, my distance wasn't exactly correct, so I'm actually gonna go back to the distance, and I'm just gonna type 55. This should make sure that we get everything on our way. Yes. So that's about it for the inactive group. So what I'm actually gonna do now is, under the inactive group up here, I'm just gonna toggle off show mesh and just put on dots instead, so we don't, so we can't see. This also gives the build-up effects. As you can see now, we have at least the base done for now. So moving on to the active group, I'm gonna create a new dynamic set, and I'm gonna call it fast turn. So the fast turn is where we're gonna handle all the rotating stuff. So let's right click and say group and pick the fast group, and then right click conditions, standard, and the particle age. In the particles age, we're gonna set the event to enters group. So when a particle enters the group, or is within distance of our dummy, we are gonna output a true value from this one. So what we're actually gonna be doing is we're gonna be rotating the particle over several frames until it hits the original rotation or alignment. So if you remember, in the set params, we've used the set alignment, and we actually rotated 180 degrees, which is which I found is this kind of the standard is and half a circle. So it's it's giving this build-up effect. Also making it also makes sure that when the particles are born, they are kind of, the new particles are actually facing the old one, so it just makes the effect look quite nice. So how we're going to do this is when the particle enters the group and the fast group, we're going to start a timer. So if you're going to helpers, standard, and there's one called timer, and this needs something first. First of all, there's a start, and this we can plug out to the particle age. So the timer starts as soon as the particle enters the group. Then it needs the particle, which just points to the fast particles, and then there's an amount of frames. Now for this, I have found that the fast particles need to turn at 10 frames, and then we are gonna, actually you can say, for example, if you open a calculator, you can say 180 divided by the number of frames. So if you divide it by 10, you just say 18. So it's an easy number to calculate with. So I'm gonna create a new set alignment node. We're gonna go into operators, standard, set alignment, and this alignment needs two things. First of all, the particle alignment, so we're gonna hook it up to the timer's particle output, and alignment also to the particle output. And the rotation, as you remember, we set up here in the x-axis. We're gonna do this again, however, as we just calculated from our calculator, we need to use 18 degrees per frame. So this means that for 10 frames, this our particles are going to move 18 degrees every frame. So if you start looking at this, you can see we have this nice build-up effect. Whoop. However, as you can see, it doesn't stop. It's kind of have this wavy motion, and that is because this will continue no matter what. So if you right-click on the green one and expose the on input, we're gonna align it to the timer out. So if you go back to frame 0, you will see that we get this nice effect. However, there is a problem, and it doesn't make a full turn. And for some reason, I'm not really sure why, because I'm not that experienced in thinking particles yet. You need to take the amount of frames you want it to do and plus it with 1. So if you use it over 11 frames, we're gonna have a perfect build-up effect. You can see now we have this awesome kind of clumpiness to it, and then everything rotates back to place, which is what we want. So this is actually the effect done for now. However, I found that if you need some variation to kind of keep the effect interesting and not have this exactly to counter this clumpiness it gets up here. So to do that, this is why we've made the slow group. We are gonna actually have exactly the same as this. So if you're gonna go on, if you take the active layer, you can see we have our fast turn dynamic set, and if you hold shift and drag, you can create an exact copy of this. And I'm gonna rename this, and you do that by just clicking once again on the name of your selected dynamic set, and I'm gonna call this slow turn. And in the slow turn, we are of course gonna have to change the group. So instead of fast, we're gonna pick slow, and I think that twice as slow is nice. So we're gonna say 20, and remember we have the +1, so it's 21. And for alignment, we're just gonna divide this by 2, so 9 frames. However, now we need to actually make sure that some of our particles actually make it to the slow group, because at the moment everybody is going to the fast group. So if you go back to our activate, and I'm just going to roll this out because we're going to need a bit more view for this. We're going to create some more logic in here to make sure that it goes to either the fast or the slow. So I'm going to rename this group node, and you rename this just exactly like you rename the dynamic set. So I'm going to call this the fast_group. So now I know this is to the fast, and shift to drag for our copy. I'm going to call this slow group, like this, and remember to change the group to slow. Alright, so this is what we have so far. What we need to do now is create a helper, standard, and then random, and link it to the inactive particle group like this. So what this actually does is create a random number for every particle that passes through it. So we have around 1700 fragments, so it will calculate an individual random number for every fragment. And at the moment it goes between 0 and 1. So I'm gonna leave it at this, and for the new value per call, this is, you can take, or you can just put it on animation if you want. Then every fragment will have the same number all the way through the timeline, instead of each time this one gets called per frame. So what we're going to use this for is actually take a percentage of each, or of all our particles, and move them to the slope group. And the way we do this is creating a new condition. So we're going to right click condition standard and threshold. And this threshold, we're going to say, tick the inside box, put the threshold 1 to 0 and this to 1.5. So this actually means in what's called in reality, this means that 50% of the particles are going to the slow group, while 50% are going to the fast group. So half-half, which I find is between 50% and 75% to the slow group, actually makes a pretty nice result. So we're gonna take the value of the threshold and link it to the value of the random, and we still have to make sure that they are within distance. As you can see, this one only takes one input, so we can't both link the distance and the threshold to the same on input for the group. So we're gonna have to create a helper, standard, and this takes two booleans, or two that can be true and false, and if they're both true, this is also gonna output true. So if the distance to the target is between 0 and 55, and the threshold is between 1 or 0 and 0.5, this one is gonna output true, and the particles are gonna go to the slope group. However, and we're gonna need a bit more for this, we're gonna create a standard, helper, and invert, and the output of the AND are gonna, so this actually means if the threshold is in between this actually means if this isn't true, then this will output false, and this will invert it to be true. So if it's true, we are gonna, and we're gonna need another AND like this. So if everything is put up yes, so that actually means if the particle isn't a candidate for the slope group, it means it's a candidate for the fast group, and this little logic actually does that. So if we're gonna enable our wireframe out in our 3D view again and go back to 0, and we can start doing, you will see that we have a difference now in the wireframe color. This means that our logic is working, and some of the particles are going to the slope group, and some of them, the others, are going to the fast group. And let's see the final result here. So you can see we kind of countered this clunkiness there's up here and created a nice variation to add some interest to the rest of the surface. And you can actually go even further and split them up to have some that are even slower or even faster, to really create some very nice looking variation. However, I think this is actually all there is to it. I hope you learned something and liked it, and of course if you have any questions, you're more than welcome to throw me an email. I'll do my best to answer it. And I would like to thank Risto Villev from Seeker Society for actually helping me achieving this effect. So thanks, buddy. You're a great inspiration for Thinking Particles guide out there. But with that being said, I'm gonna say thank you for watching this, and I hope you liked it. I'm sorry if my accent or my English isn't as good, but I hope you learned something from this. So hope you liked it, and thank you for watching. See you there.